Okay, so here's a video for problem 2 in homework number 17. I've kind of started a video already and it got messed up, so I'm going to narrate some of what I've already written down. All right, so this frame here has this piece ABC. You can see it's one piece, and it's connected to this other piece right here with a slot in it. And then this diagonal, it's got the forces FD and FF on it of 8 and 3 kilonewtons. And the dimensions, these two are both 2.5. This is 3 meters, here's 2 meters, and this is 3 meters. And we want to find the components of the forces acting on member ABC at each pin. Okay, so as I mentioned, there were some extenuating circumstances here with my video, and I had to stop it, so I lost the video. So here you go. What I did first was to find the reactions, or set it up to find the reactions. And we know at first glance it appears that this could be statically indeterminate, so we have to be a little nervous about that because we have more reactions than we're going to be able to find with 3 equations. We have 4 unknowns and really only 3 equations to deal with. So we have to be on the lookout for it being statically indeterminate. Over-constrained is another term that we use for that. But I set up an equation here based on the sum of the moments. I could also put the sum of the forces and add those equations in there, and that might have helped. But I decided I was going to isolate this piece first. So that's what I did. Now, this approach that I'm taking, might be the long way around. There might be other approaches that could be shorter, but let's because there are a number of let's say another number of ways to write the equations. They're not like independent equations, individualized independent equations, but there's other ways to in statics to if we were to say, like, okay, if I decided to write the sum of the forces into this, I would start entering into these variables into this as well. But then as I started to do individual parts right there, that would set up another system of equations, and I could go about that route, but they wouldn't be. Some of them wouldn't be independent equations. I'm trying to make that clear. It's kind of hard to articulate. So anyway. So I get this equation right here, which is the sum of the moments taken about here. So I get everything in terms of this REX and REY, right? Those are 2 unknowns as part of this. And I almost wish I had not changed these into newtons from kilonewtons, but I did, so I'm going to stick with it. I take the free body diagram of this individual piece right here, trying to take advantage of the fact that I know that the magnitude has to be along a line of action because this is a 2-force member, right? Because there's a 2-force member, I can get this. I also am taking advantage of the fact that this is a slot. So the force is only in the horizontal direction. If I take the sum of the moments about E, I'm able to get a relationship between this force and this force, these two. That's going to be helpful to us. So that's going to be my second equation, right? Remember my first equation related this. So now we have 2 equations and 4 unknowns. That's not good. We need 2 more equations that only have those things in there. So we take the sum of the forces in the x direction on here, and we know we reintroduced REX here, a portion of FBD, and all of FC into here. So now we have equation 3, right? So our last equation that we need is in the y direction here, and we have a relationship between, looking back up at this, we can relate the vertical direction here and the vertical direction component portion of that. We also notice that my guess is probably wrong. I don't know, of FBD. We'll see. But we have four equations and 4 unknowns. And so my strategy to solve this is to go after FBD right here, right? So I already have FBD, so I want to replace this with something in terms of FBD and replace that with something in terms of FBD. And I can do that if I rewrite the equation 1, this one, in terms of REY. And then I can take this REY with the FBD and replace that in here. So now I have REX in terms of FBD. Then I can rewrite my equation 2. So I get FC in terms of FBD. And then I could put all three. I could put this one, and this one all back into this equation and solve for FBD. And so that's what I do. And what I end up getting is a negative 7,179, which I know means that this cross member is actually in compression, which kind of makes a little bit more sense than making it in tension. And then I also am able to use that and go back for that FC and get what this value is going to be. And then I'm also able to get my reactions. Okay, so here's where I stopped when I had my other video. And I can continue on with the rest of this. Okay, so this would be now page 5. No, I guess I'm getting finished on the rest of this page, what I have right here. Okay, so something I didn't do in the, I think actually pretty much all I have to do left is the RAX and the REY. So maybe I should have put those back up here next to this. Would have been a good idea, right? To say that, yeah, some of the forces, I had room for it in the x direction, was going to be RAX plus REX, and then minus 3,000 equals 0. And I can later on, I wish I had not already numbered these things. I think I'll just go ahead and number it number 5, even though that doesn't make a lot of sense in terms of the chronological part of this right here. And then the sum of the forces in the y is equal to 0. And I got RAY plus REY minus 8,000 equals 0, and I'll call that equation 6. So on here, from equation 5, I say that I have RAX plus, and I think, let me write down these arrows. I should have put all these arrows in here. This one was FC in that direction. Okay. And this one was REX was positive. Okay. So that's going to be 1,835 minus 3,000 equals 0, and therefore RAX is going to be 1,166 pounds, no, newtons, jeez. And I do believe that is also horizontal. And then from equation 6, we had that RAY plus REY, 2,666 right there, minus 9,000. So 2,666 minus, and we get RAY was 6,334 newtons, and also up. Let's see if that makes sense, that this is so much more than that. Okay, I guess. So this is trying to push this thing over, so this has to come up to counteract that. I guess so. Yeah, so yeah, so this would be like kind of, this would tend to make this one have to pull down. I guess I can appreciate that. So let's say I've write down, summarize what the answers are. We'll go at A. RAX 1,166 newtons that way. RAY is going to be 6,334 newtons up. Okay, so at B, we're going to get our, I might just go F. I'm going to call it F, B, and I'm going to call it FBD. You know, this is going to be what FBD is, but this is going to be, we decided it was in compression. Yeah, okay. And we got a value for the FBD of 7,179 newtons. And it was coming up at an angle with respect to horizontal of 21.8 degrees. And then at C, FC right here was, where are you at? Okay, so here we got to be a little careful. This is the force on this right here. I ended up getting a negative number. I thought it was pushing back right there, but it ends up pulling onto this thing. So it's actually coming to the left to act on C. So C is actually to the right on this one. I'm pretty sure. So there you go. Voila. Not the smoothest of videos, but it was a video.